So one of the features that a lot of people like about using a multiple linear regression model to help with forecasting for time series is that you can add in external or exogenous variables as explanatory variables into the model. So you can add in just about anything. You can add in anything you want. Obviously, it should have some kind of correlation with the outcome variable, the dependent variable. And it's going to be something other than just a history of what we've seen before, so the historical pattern. So that's one of the benefits to using a regression model versus something like an exponential smoothing model. The problem sometimes becomes, though, depending on what we choose as that other exogenous variable, the other x independent variable, is will those data values for the future be known so that I can use them to make future forecasts. So for example, what if we added, instead of just looking at the historical demand patterns, the amount of money that was spent on advertising by some government agency perhaps, in Australia to try to get tourists to come each quarter. Marketing people will tell you that the more money I can spend, the more people I will have, right? The bigger the reach, the more draw, all that's good stuff. All that stuff you learn in marketing classes. So we could add the advertising dollars spent per quarter into the model easily, right? And the question then becomes, if I need to forecast 2 years out into the future and I have a column, a variable, for advertising dollars spent during that particular quarter, then I would need to know how much I'm going to spend for the next 2 years on a quarterly basis in order to make the forecast. That's probably not unrealistic, perhaps, especially if we only go out 1 year. But one of the things that we might also consider is that forecasting based on money spent for advertising, you might actually want to lag that a little bit. So the money I spend this quarter may not actually affect visitors for the current quarter. It might affect someone a quarter or 2 quarters down the road. So you have to think about those kinds of things as you move along. But that is one of the advantages that people like about the regression-based model. So the other thing we have to talk about is partitioning the data. So many times what we want to do is partition the data into 2 subsets for a time series. So we'll partition it into a training period and a validation period. Remember, a partition means we take the whole thing, split it up. There's no overlap between the 2 periods in this case. So the training period has more historical data. The validation period, we're holding out. So what we'll do is we'll build or fit the model on the training period and then test it on the validation period. So test it on stuff it has not seen yet. And then look at the accuracy metrics on just the validation period to tell us whether or not we think it's a decent model that we could use. If we're happy with what we get for the accuracy metrics for the validation period, then what we can do is put the partitions back together in the big one, refit the model. The coefficients will be different, right? Maybe not tremendously different, but they may be different. And then we'll use that new rejoined data and fitted model to forecast out into the future.